Hello everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over exponent rules and more specifically negative exponents. The first thing to know when we're working with negative exponents is that they're not proper. Just like in life, we don't want negativity, and more specifically for our exponents, we don't want negative exponents. So to be able to simplify properly, we have to make those exponents into positives. So to make it into a positive, if our negative exponents in our numerator, we'll bring it down to the denominator, which makes it positive, and vice versa. If it's in our denominator, we are going to move it up to the numerator and make it positive. So we're going to apply those rules to more straightforward problems and then step it up and continue using our exponent rules we've seen prior. So let's look at these examples so we can fully understand what we're working with here. So we have a negative 3x to the negative 7th. Something very important to note is when we say we can't have negative exponents, we truly mean the exponents. Here our negative 3 is our coefficient. This negative 3 coefficient has an exponent of 1. It has this one exponent here. So this has a positive exponent of 1. So we are not going to do anything with it. We can have coefficients that are negative. We cannot have exponents that are negative. So we're going to leave the negative 3 where it is. However, we said we have x to the negative 7th. We can't have a negative exponent, so this is technically in the numerator. This is all over 1. So instead of having it in the numerator, we're going to take it down to the denominator and make it positive. So it's going to be negative 3 divided by x to the 7th. And that will be my final answer. I no longer have negative exponents. I have a negative coefficient, but that's okay to have. Let's take a peek at this one. We have 2 divided by y to the negative 3rd. That 2 is going to stay where it is. It has that positive exponent of 1. However, y to the negative 3rd has a negative exponent. So instead of it being in the denominator, we're going to move it up to the numerator and make it positive. So this is going to become 2y to the 3rd power. I took it from the denominator, moved it up to the numerator, and left it where it was. So my final answer, I can write that bigger here, is 2y to the 3rd power. Once again, I just took that negative exponent and moved it from the denominator up to the numerator. Let's try some problems we were stepping it up now. Now we have this problem. We've seen something like this before. We would use our product rule, then our power rule. So our product rule tells us to multiply our coefficients and add our exponents. So our little dance comes into play again. So I'm going to use my product rule first to work with the inside. So the inside tells me to multiply negative 3 and negative 1. Our coefficient here is negative 1. Negative 3 times negative 1 is positive 3. Then I'm going to add my exponents of my like terms. So I have v squared and v to the negative 4th. 2 plus negative 4 gives me a negative 2. So I'm going to v to the negative 2nd power. Then I have my u to the 3rd and u. That u has that imaginary 1 as the exponent. So we have that 3 plus our 1 gives me u to the 4th. And now we have to apply our power rule. We're going to put it to the 3rd power. So we're going to do 3 times 3 times 3 because our coefficient gets raised to that power. So 3 times 3 times 3 is 27. We multiply our exponents. So negative 2 times 3 gives me negative 6. And 4 times 3 gives me 12. Now we are left with this answer. And before, we would just leave it as is. That's our final answer. However, we are so smart now, we know that we can't have negative exponents for this to be proper. So I'm going to take my negative exponent and put it to the denominator. So 27 is going to stay where it is. U to the 12th is also a positive exponent. And then I'm going to put it all divided by v to the 6th. I took my negative exponent and put it into the denominator. Let's try another rule where we're going to use the product rule again to see how we would complete this problem. Now we have this problem here where we're going to use our product rule. So our product rule tells us to multiply our coefficients and add our exponents. So we have negative 3 and 4. When I multiply them together, I get a negative 12. Then I'm going to add my exponents. M is just going to stay by itself because there's no other m in the other term. We have n to the negative 7th and n to the 3rd. Negative 7 plus 3 gives me negative 4. So I have n to the negative 4th power. And then I have a p squared and p to the negative 4th. Negative 3rd, excuse me. So 2 and negative 3, I add them together, I get negative 1. So I'm going to have p to the negative first power. Now we're going to take all our negative exponents and put them to the denominator. We have to remember that negative 12, though, is not a negative exponent. That is a negative coefficient that has an exponent of 1. So it's going to stay where it is. So it's going to be negative 12. M also has that positive exponent of 1. And to the negative 4th, we can't have negative exponents. So we bring it down to the denominator and make it positive. Same thing here. We're going to have p. You can put p to the first, but we are supposed to be, remembering, we are mathematicians. We know that p to the first power is implied. If we just put a p, that means p to the first power. So we're going to leave our answer like this, and that would be our final answer. Now we're going to take a look at some problems where we're going to use the quotient rule. For the quotient rule, we have to remember our little dance, our little rule, that we are going to divide the coefficients and subtract the exponents. Little dance here. So we are going to see, can I evenly divide the two numbers together? 6 divided by 4, that's going to give me a decimal. We don't want decimals. We always want simplified fractions. So the next step is to check, can we take out a GCF? Well, 6 and 4, they are both divisible by 2. So I'm going to divide a 2 out of both of them. So 6 divided by 2 leaves me with a 3. 4 divided by 2 leaves me with a 2. Now we're going to look. We have to remember, we just said we divide our coefficients, subtract our exponents. So we're going to subtract the exponents of the like bases. So 1 minus a negative 3, I can write it here, becomes a plus 3. Our integer operations are so important, especially when we're doing quotient rule. So 1 minus a negative 3 becomes a plus. So 1 plus 3 gives me 4. So I'm going to have m to the 4th power. We're going to leave them all in the numerator and then move them later. Then we have 2 minus 4. 2 minus 4 is negative 2. So I'm going to have n to the negative 2nd. And then 4 minus the 1 gives me 3. Now we are going to take our negative exponents and we're going to bring them down to the denominator. So I'm going to have 3 divided by 2. M to the 4th stays where it is. N to the negative 2nd. We don't want negatives, so we bring it down to the denominator and make it positive. P to the 3rd stays where it is. Another little trick to see is we had n squared and n to the 4th. There's more n's in the denominator, so once we subtracted, there should be more left here, so that's why we have it in the denominator. I like to make my students use our exponent rules of subtraction and then move it so I can see that they're properly applying these, but if you can visualize and see, wait, there's more n's in the denominator, I leave it down there, you can do that. Let's try one more problem where we're going to use the quotient rule to make sure we're fully understanding this concept. We have this problem where we're going to use the quotient rule. Our first step is to divide our coefficients. We have 4 divided by 2 gives me a 2. Then we have to subtract our like basis exponents. So 3 minus the 1 gives me a 2. Negative 4 minus the 1 gives me a negative 5 for our exponent of p. And then negative 6 minus a negative 3. That minus a negative becomes a plus, so we're going to have negative 6 plus 3, which gives me a negative 3. So I'll have q to the negative 3rd. Just like before, we can't have negative exponents, so we're going to take them and put them into the denominator. So I'm going to have 2r squared, that stays in the numerator. They both have positive exponents. And now it's going to become p to the 5th, q to the 3rd. I take my negative exponents and bring them to the denominator and make it positive. So I hope all these problems were helpful when we're using our exponent rules to just apply now. If our exponent becomes negative, just the exponent, doesn't matter the coefficient. If our exponent becomes negative, we take it and we put it into the denominator and make it positive. So I hope this was helpful and thanks for watching.